So in this lecture we are going to talk about traces of line. There is a simple procedure that we have to see today. So what are traces? Traces are simply the intersection of the horizontal plane or the vertical plane with the line. If it is not the line, then it should be the extension of the line. So it means that if there is a line, we try to extend the line, it is going to meet either the horizontal plane or the vertical plane, even the extension. So the point where it seems to intersect by extension or by line itself is called as traces. So when the extension is meeting to horizontal plane, this is HT, and when the intersection is meeting at the vertical plane, it is called as VT. So these are the examples where the line was parallel to vertical plane, and in this case the line was parallel to the horizontal plane. So you can see that in this case we are going to get only horizontal trace, and in this case we are only going to get the vertical trace. When the line is oblique or skew line, then you can see the intersection is possible both with horizontal plane, okay, and with vertical plane. So the dark line which you see is the actual line, and the extension is going to meet the vertical plane, creates VT, and the horizontal plane called as HT. So there is a simple procedure. This is the realistic 3D procedure which you see here is very simple. Now what to do when it has to be drawn from the front view and top view. So the procedure, in order to make it simple, the procedure is, as you can see here in red font, extend the top view. TV extend means extend the top view till XY line, correct? And from the intersection draw the vertical line. This line, vertical line, will be intersected by the extension of front view, that gives you vertical trace. And similarly for horizontal trace there is a procedure. So let us see this procedure one by one. In this case, as you can see here, this is the projection of lines. This point AB is top view, correct? This is the top view and this is the front view. So we can see that since front view is parallel to XY line, we are not going to get any intersection. Fine, so we cannot do anything here. In the top view, you can see that there is an inclination. So let us extend. What is the procedure? Extend the top view till XY line. So okay, extend the top view till XY line. Draw a vertical wherever it cuts XY line. So you draw a vertical XY line. Now go to the second view and draw the extension of this second view. It cuts the vertical line and we are going to get a point. Now what is this point? We have started the procedure with top view, so we are going to get VT. So remember, TV is going to give you VT, okay? TV will end up with VT, fine? And the other one is FV is HT. So TV VT is mirror kind of images. So TV is going to give you VT. Let us look at it again. Extend top view till XY line, draw the vertical from intersection, then another view will target this vertical line and get a point here. This is TV, so we are going to get VT. Now in this case, correct, here the line is inclined to HP and parallel to VP, so this is going to be the front view. In front view also the same procedure. So TV gives VT and front view gives HT, correct? So extend the front view till XY line, okay? Then draw the vertical from the intersection. This vertical will be targeted or intersected by the front view extension. You are going to get a point. This point is what? Since we have started with the front view, we are going to get HT. Okay. Now look at this example. This we have already seen in the previous slide. Look at the example of skew line. So let us start with the front view. Extend the front view till XY line. The same procedure is going to be followed here. Extend the front view till XY line. From the intersection, draw vertical line. This vertical line will be intersected by another, correct? And here we are going to get the intersection. What is this point, ST or VT? We have started our procedure with front view, okay? So we are going to get HT. Now we have to find out VT also. So extend the top view till XY line, we get the intersection here. Okay. From this intersection with XY line, draw a vertical. This vertical will be intersected by another view. So you got this point here. This point is what? We have started with top view. We are going to end with VT. Fine. Let us quickly see one problem. Line AB 175 mm long. So this is going to be the true length. Inclined to VP parallel to HP. So when the line is parallel to HP, in the top view we are going to get the true length and the true angle. Fine. Front view will be distorted, will be giving you apparent length. So front view length is 125 and A is given 50 mm in front. So we draw the line here. So point A we will first of all plot. A is 50 mm in front and 75 above. So as we have discussed already, this direction is above. Okay. This direction is below. Fine. At the same time, the same below direction is front. Okay. And this is behind for top view. So similarly, based on the data given here, we can plot point A. So point A will be plotted here. 1, 2, 3 grids means 75 mm above we have plotted this fellow. Then similarly, the length of front view is 125 given. So 1, 2, 3, 4, 5. We can draw a line. Point A is 50 mm in front. So in front is below direction. So 1 grid, 2 grid. So this is going to be D. Now it is given that the length of line is 175. So we have to draw a line of 175. It may be here, or it may be here, or it may be here, anywhere. So that direction is not known. So what to do in this case? We know that on the same projector, the front view and the top view points are going to be followed. Correct? It means if A dash is here, A is going to be followed on the same line. And if B dash is here, B is going to come somewhere on this straight line itself. So we can draw straight line. Okay. And then on this straight line, we can cut an arc of true length, that is 175, and we are going to get this point. Let us join it. We have to then find out the traces. So this is front view. So we remember our procedure. Top view gives VT, okay, and front view gives HT. What is the procedure? So here we get only front. Here extension is not going to intersect XY line. Extend the front view till XY line. From the intersection, draw vertical. This vertical will be intersected by other view. You get a point here. This point is what? We have started with front view, so we are going to get top view, so we are going to get HT. Maybe I have explained it as front view, so it is top view. So we are extending top view, got a line, and so on. Let us see the example of skew line. It's a skew line. Line AB has end A, location of A above given and front is given. So we can draw point A. Above means above XY line 1, 2, 3 grid, and HP in front of. So front means downward 2 grid points here. Correct. So this is front view. The other end B is 175 mm above. So we can count 1, 2, 3, 4, 5, 6, 7. 7. Okay. So this is going to be B. 175 above. Okay. And then 175 in front. So similarly somewhere 175 will come here. But we don't know this distance. Where do we make this point? Either here or here or here. So end projector distance is given as 275. End projector is what? The line containing AA dash and the line containing BB dash. These are called as end projectors. So the distance between these two lines are given as 275. So we can draw a line here, and then between this and this line you can draw this as 275, and here we can draw a vertical line where 175 above and 175 in front we can plot, and then we can join AA dash and A dash, B dash and AB. Now let us follow the same procedure. Extend the top view. So we are extending the top view, so we are going to get VT. Okay. Extend the top view till XY line. Draw the vertical from here. Then other view will cut this extension. Correct. So we are going to get VT here. Fine. Then extend the front view till XY line. Fine. Draw the vertical, and this vertical will be intersected by other view. We are going to get HT. Correct. So this is all about the traces. Now let us come to the realistic problem where we will be given mixture of data, correct? The problem may not be very simple, as you can see here. The location of A, let us given, see that it is given, location of B, let us say it is given, and it is given that location of A is given, correct? These red points are given in problem, and it is given that HT is this much above, let us say 25 mm above XY line. This is given. So how to solve the problem? In that case, what we will do, we will draw whatever data is given. So A we will plot somewhere here, then with the projector distance and all, B is given here, and A dash is, let us say, given here, correct? These data is given, so we can join A dash B dash, correct? And this point HT is 50 mm above, so we can draw this line here, and we can say that on this line somewhere HT is going to be followed. Now what to do? This is A, this is A dash, okay, and this is B dash. So how to solve this problem? So what we will do, immediately when you realize that this is the kind of case, you draw this procedure somewhere in rough, correct? Somewhere in rough work you can draw here that this is the condition, and if it is going to be A dash, and this is B dash, and this is A and B, so we can draw the entire procedure in this particular way. Now we have to backtrack this particular procedure. Let us see how to do that. So what we have to do, you have drawn the possible data here, whatever is possible, and then somewhere imagining that we know all the data, we draw the entire thing with the same procedure which we have followed initially. Now look at this. What is the relation between this point A dash B dash and HT? So you can see that if we extend A dash B dash, it is going to intersect here. From intersection we got a vertical line, and this vertical line is going to contain HT. So let us do the same. We extend it here, okay. We got intersection here. From intersection we draw the vertical line, and on this intersection, so here you can say that this is going to be HT, correct? Now what is the relation between this HT and A dash? We can see that it is joined on a straight line, so we can join it on a straight line, and then a straight line, on the same straight line we are going to have point B somewhere, okay. So we extend this line here and say that B will be somewhere lying on this particular line. Now you can see that this line and B has got another line which is coming vertically from B dash. So we draw a line vertically from B dash, intersects here, and we get here point B, correct? So that is the hint or clue, you can say, that where you are getting a mixture of data. So what you try to do, create the model solution or model process of the same, and try to backtrack that whatever data is given and whatever is missing, what is the geometrical relation between the points, and that is how you can get the entire problem solved. Okay, that's all from now. Thank you.